So there are various libraries for importing CSV data. It doesn't really matter when the file is small, but when you have large file, then the speed matters. So let's see how we can test which package is best when you're talking about large data sets. So I'm using these packages or libraries. And with that, we can try different ways of importing CSV files. And first of all, we will need some data. But before we need the data, I'm just switching off the scientific notation. Otherwise, by default, R displays large numbers as scientific numbers, which we don't want. So let's run it. And now let's create a big data file. So when I say big, let's use a number, let's say 1 million records. And using that, inum equals 1 million. So I'm going to create a data frame. And I'm going to use the Wakefield package. So let's start. First of all, I'm creating an ID field using the Wakefield package. So I'm creating an ID field with 1 million rows. So with that, we can have a number of other fields also, like name, sex, date of birth, age, height, etc. To make it still bigger, I would need some more data fields. We need some more fields. So I'm just creating some notes fields. So notes 1, and let's have some more notes there. Okay, let's run this command and create our data frame. So we have our data frame now. Let's save it very quickly on my desktop. And then we'll start timing the reading of this data. Before we go into the timing mode, let's run each statement first, just to see how the data is imported using different packages. So this is the base R read.csv, and then this is a Rio package, and I'm using the import function. This is the data table fread function, and then there is new package called vroom. You can import the file as well. So because vroom actually displays the text on the screen, so I put that show column types equals false, because that might also slow it down. So now let's move our story further. Now we are in a mode where we can actually go and benchmark the timings for all by importing this CSV file, which contains 1 million records. And how do we benchmark it? I'm going to use the micro benchmark function from the micro benchmark package. So what it does is you run each function or each command there, and then it'll run it 100 times and then give you the median times, etc. So let's run it. It's going to take a long time. So micro benchmark is running each command 100 times. That's why it's taking some time, and let's speed it up and see our results. So the results are out. We have our data frame called MBM with 400 observations or rows in that, which contains the timings. So we can quickly browse through the MBM data frame. Here we go. We can quickly plot it using the auto plot feature or function. But we're going to do it in a nice fashion. I'm going to use the ggplot command to create a proper chart. So I'm using ggplot, and the data is MBM. On the x-axis we have the expression, on y-axis we have the time, and I've converted the time into milliseconds. So let's see what the chart looks like. Before we see the plot, let's fix a few things. So I'm using the library stringer to do the string wrap on the x-axis so that the labels can be wrapped up. Instead of long lines, they can be wrapped up. Let me fix the labels and let's run it. Let's also fix the legends, because the legends are being shown, they're unnecessary. So I'm going to say theme legend dot position equals none. So with that, the chart looks okay, and if we run it, we have a nice chart, and we can see the timings. The first one is the standard read command, the second one is Rio, the third one is the fread, and the last one is a vroom. We can also convert these timings into seconds, and if I run it, we can make a better sense out of it. Let's zoom it up, and we can see that, in the first instance, when we were using the read CSV, it was almost like around 7 seconds, and then it starts going down to almost less than around a second or so. As we are all budding data scientists, we have another question in our mind. Can we display this in a better way in a table format? Yes, we can do that. So let's do that as well. So I'm going to use the summary table. I'm going to create a summary table using GT summary and dplyr. So here we go. We have library dplyr and library GT summary. So I'm going to use that MBM data frame and create a new column in that to convert the times into seconds. And by using the GT summary package or library, we can create a nice table out of that. So I'm using the table continuous command from the GT summary package. I can write it this way also. And then I'm going to say I want to include the expression and the time in seconds. So these are the two fields which we want to include in our final table. So I'm going to use the include command, include equals expression and time seconds. That's fine. And what are we going to do? We need to specify the variable which we want to analyze. So in this case, it's the time in seconds. So if I run it, we get a nice and simple summary table which gives each expression which we used and the median timings for that, and also the IQR, the interquartile range. I hope you found this information useful and practical. Thank you very much for watching it, and I'll see you in the next one.